16,000 feet up. Your lungs are working twice as hard for half the air. Your head is pounding. Your fingers are tingling. This is altitude sickness, and at this elevation, it can kill you in a matter of hours. The person walking next to you isn't struggling at all. Same air, same mountain. Their breathing is steady. Their blood is carrying oxygen like it's nothing, like their body was built for exactly this place. And in this timeline, it was, because they're not Homo sapiens, they're Denisovan. And in this version of history, they never went extinct. Here's what most people think happened to the Denisovans. They went extinct, full stop. Wiped off the map 30,000 years ago, replaced by us, gone. That's not actually true. Denisovans didn't disappear. They got absorbed. Every time a Denisovan and a Homo sapiens had a child, a little more of that population folded into ours instead of vanishing from the Earth. Today, some Melanesian and Aboriginal Australian populations carry up to 5% Denisovan DNA. A 2025 study even found a Denisovan inherited gene called MUC19 still running in the immune systems of millions of people with Indigenous American ancestry, a survival tool handed down across 60,000 years, still doing its job. So the honest answer to did Denisovans go extinct is not entirely. A piece of them is in you right now, whether you've ever heard their name or not. But here's the branch point. What if that absorption was never complete? What if one population never had the chance to fold into ours at all because they never met us in the first place? In 1980, a monk meditating in a cave on the Tibetan Plateau found half a jawbone. It sat in a monastery, then a university drawer, for almost 40 years before anyone figured out what it actually was. It was Denisovan, and it was old, at least 160,000 years old, found in Baishiya Karst Cave at over 10,000 feet above sea level. That's a 100,000-year head start most explainer videos skip past, because the earliest evidence of Homo sapiens permanently living at that altitude on the plateau doesn't show up until around 30,000 to 40,000 years ago. Here's the part almost nobody mentions when they tell this story. Scientists still don't actually know if those specific Tibetan Denisovans carried the gene that lets modern Tibetans breathe thin air so efficiently. That gene, EPAS1, is confirmed to have come from Denisovan ancestry, but no one has recovered Denisovan DNA from that high-altitude population itself. It's a real open gap in the research. We're extrapolating past what the evidence confirms. But if any population on Earth had that gene 60,000 years before anyone else, it'd be this one. So here's our branch. In this timeline, that gap closes the other way. That Tibetan Denisovan population isn't a way station passed through, it's a refuge, isolated by terrain that was actively hostile to everyone else on the planet. And when Homo sapiens finally reach the plateau around 30,000 years ago, they never find them. Not because the Denisovans are gone, because the mountain is still doing its job. For almost the entire time Denisovans have been known to science, nobody knew what one looked like. No decent skull, just fragments, a finger bone, some teeth, that one jaw. That changed in 2025. A skull found in Harbin, China, back in 1933, nicknamed Dragon Man, sat misclassified for decades. Researchers finally pulled DNA and protein fragments off hardened plaque on its teeth and matched it to Denisovan lineages. For the first time, we had a face, heavy brow ridge, wide, low skull, a jaw built like it meant business, and a brain case sitting comfortably in the same range as ours. In some individuals, bigger. Now push that another 60,000 years forward from first human contact with the plateau. 60,000 more years of isolation under some of the harshest selective pressure on the planet. You're not looking at a caveman. You're looking at a population potentially even more finely tuned to that environment than the Denisovans of 160,000 years ago. Bigger lung capacity, more efficient blood oxygen handling, a physiology quietly outperforming ours at an elevation that would put you in a hospital bed. By every measure that matters, at 16,000 feet, they'd have won. Evolution didn't stop for them. It just kept running somewhere we weren't watching.
Here's where the fantasy version of this story usually goes wrong. People imagine a reunion, a lost cousins moment. Two branches of humanity finally shaking hands. That's not what happens. Every time an isolated human population has made first contact with the wider world across the Americas, the Pacific, anywhere the deadliest thing that crossed that boundary wasn't a weapon, it was a virus. Populations with zero prior exposure to outside pathogens have historically lost devastating percentages of their people within a single generation of contact, not from violence, but from disease their immune systems had never been trained to fight. And here's the cruel irony this timeline hands us. That MUC19 gene, the one Denisovans gave modern humans that now helps protect indigenous populations from disease, came from thousands of years of Denisovans and Homo sapiens sharing pathogens, adapting together, side by side. An isolated Tibetan Denisovan population would have none of that. 60,000 years without us also means 60,000 years without our diseases. Contact wouldn't be a documentary crew and a handshake. It would be the fastest, quietest extinction event in this hypothetical's history, just delayed by 60,000 years, and finished off by something as small as a common cold. So this timeline doesn't actually save them. It just moves the ending 60,000 years down the road and gives it a smaller, quieter cause. But that's not really the point of asking the question, because somewhere in your own cells right now, a Denisovan already survived contact. Not on a mountain, not as a separate species standing across from you, inside you, in your immune system, maybe in how your ancestors handled a cold night, or thin air, or a virus that would have killed someone without that borrowed piece of code. They didn't go extinct. They just stopped being separate from us. That's the real branch point. Not whether they survived, but that they did, just not in the way anyone expected.